When we think about the origin of life, a lot of people focus on the building blocks of life and how they can come together to form the first living cell. We don't consider that for all of these processes to happen, something needs to be powering them. And that is where energy comes in. What I'm interested in is on how this energy could have become available for life to actually appear. To understand how life actually got the first energy to keep going, we need to understand how life uses energy nowadays. For life to exist, there needs to be potential energy available to it. In a sense, you can think of life as a book on a shelf. So when you have a book that is high up, if we push it, the book will fall, and the energy of that will be dissipated as heat and sound. The difference in the states of the book between being on the shelf or being in the ground, that is the potential energy. What makes life pretty unique is that life couples two types of reactions. The first one releases energy, much like the book on the shelf, and the other one uses that energy to do something else. That's very much like an engine in your car, where fuel is burned to power up the movement of the wheels. The first type of reaction is something we call a redox reaction, where electrons hop from molecule to molecule. And this process releases energy. A good example of a redox reaction is our digestion. We eat a burger, for example, and our bodies, what they do is react it with oxygen, so that both of these components are transformed into CO2 and water that we breathe out. The energy stored in the burger is released for our bodies to use. And the way our bodies use it is by synthesizing a very important molecule called ATP. So for this reaction that makes ATP to happen, there needs to be a coupling of the two reactions. Once the cell has synthesized ATP, then ATP will be used for every single process within the cell that needs energy. This energy coupling system could not happen without enzymes. This process would probably be too slow for life to even exist. But of course, back when life started, enzymes hadn't evolved yet. They weren't there. What I'm interested in is finding out whether there's an inorganic system that, in a similar way to how life works, transforms simple inorganic molecules, such as CO2 and H2, into simple organic molecules. We know that once you have these simple organic molecules, they will slowly react amongst themselves, become more complex, and eventually become life. Remember when I said that life needed a difference in states so that the energy can then be used? So as it happens, the early Earth, it was full of these places where two different states were one next to each other. So in a sense, we could say that the early Earth was like one giant battery. We have the rocks that are full of chemicals that are rich in electrons, whereas the atmosphere and oceans are full of other chemicals that don't have that many, so that the electrons naturally want to hop from one to the other. There is actually a very special place where these two types of fluids would meet at the bottom of the ocean. We not only have these different molecules with different amount of electrons, but we also find that the basic fluids meet the acidic ocean, and that difference in their state is potential energy that could be used as long as the both fluids don't initially mix. And we also know that special type of minerals were formed that actually separated both fluids. And the only thing that could cross this barrier were actually electrons. That when this type of electron transfer is happening, the pH difference, that initially we have a high pH and a low pH, is slowly being equilibrated, so that this potential energy is actually being used to transform the simple inorganic molecules into organic ones. So in a sense, this very basic inorganic system does a similar job to how life uses nowadays. So what we do in the lab is work with very small volumes, and within a glass slide we create channels within so that our two fluids can flow next to each other. So much so that our mineral barrier forms in the middle. We can measure at the end, we can take samples and see if the pH has been equilibrated or not, so that whether the potential energy is being used. And we can also measure whether organic molecules have been indeed synthesized. So, in summary, what life does is to use potential energy to power up reactions that need energy so that it can do everything else it needs to do. For this conversion of reactions, life uses pH gradients as well. And how it happened without enzymes, we still don't know. But hopefully, this type of research will shed some light into where these type of systems working with pH were crucial.